Hello, everybody. Good evening.
Good evening, Google.
Ladies and gentlemen, please have your seats.
Shows up.
Nice running back into
So, welcome everybody to another Mobile Monday Developer Lab. Tonight we're going to have Qualcomm, and they're going to have an overview of their Tuneup, their app Tuneup kit. You are one of the very lucky few that will be actually able to see this hands-on since its launch, I think early November. A couple of important items for tonight. Restrooms are down this hall to the right. If you have to have a conversation, please, the doors are open so you guys can go outside and have a quick conversation if you have to. Just please, out of respect for our presenters. So, so tonight we have a deep dive into the active, our app Tuneup kit, and then we'll start off with Rick from Qualcomm. Please give him a hand and applause. And also, feel free to get up if you have to during the event. There's still a lot more sodas and drinks and maybe some food left over. So help yourselves for the rest of the evening. Thank you. Okay.
Thank you for coming out, everyone. Great turnout. So we're going to talk about Android app development and optimization. A lot of things we talk about apply to other platforms as well, but specifically Android tonight. How many people have heard of Qualcomm? If you have an Android phone, pretty good chance that you've got a Snapdragon processor. If you don't have an Android phone, extremely high probability the cellular radio is Qualcomm. So, in fact, over 1 billion devices, and the numbers are getting so big it's hard to keep it straight. So I'm sure most people have heard of the term perf. It's something you hear a lot at tech conferences and things like this. Obviously, perf is hugely important, but it's not necessarily the most important thing to consumers. At least not based on the studies I've seen. What do you guys think is even more important than perf?
Battery life.
And it doesn't matter which study you look at. There's been large numbers of studies. More important than OS, which is surprising. Platform, screen size, and it's consistent whether you're on Android, iOS, or Windows. Battery life is the thing. At the end of the day, if you're like me, you're looking at your phone, you're asking yourself, do I have enough power to get through the night? Because you don't want to be without your mobile device, and that puts some challenges on developers when we talk about that tonight. Obviously, profiling is something that you want to do with your devices, and you want the best performance possible. Most of the profiling software I've seen is focused on the processor, specifically CPU, some extent the GPU. Very few people are doing anything with DSP. Sometimes you'll see memory, and ironically, the things that consumers care about the most, things like power consumption, things like thermals are becoming more and more important. Excessive data usage. If you've got a 2 gigabyte Wi-Fi plan or wireless plan, obviously data is something you need to be concerned with.
I'm sorry, thermals?
Thermals.
What's that?
Thermals are how warm your device gets.
Okay.
And there's two reasons. One is you feel it in your hand, and if it's noticeably warm, it's something that consumers think about sometimes that they're concerned about. A bigger concern is if it gets warm enough, it can actually cause something called throttling, which is where the frequency drops and the performance drops.
Got it.
So we wanted to talk about, okay, if we could come up with a new profiling tool, what would we do? Something that's different than what else there. There's some great tools out there, and they all have a place, but we wanted to come up with something where you don't need a computer, where you don't need a stack of manuals, and where it's very clear how to act on the results. I look at these charts and I see all this data, but it's not immediately obvious what I need to do as a developer to act on this data. And of course, if you're a developer, you want to take your time to make your app better. You want to add new features. You want to fix bugs. profiling isn't always the top thing you want to do. So, how many Android developers do we have here? Okay. How many do profiling on their apps? Yeah, not that many, actually. And how many have actually know how much power their app consumes? Okay, one.
Well, from just Java.io this year with Project Volcano they started.
Exactly. Which is ironic, the thing that consumers care about the most.
Yeah.
And it doesn't matter, I speak at conferences all over the world, and you'll be in a room with 200, 300 people, and no one's doing power profiling. And I don't think it's because people don't care, I think they just don't know how to do it. And it's a lot easier to do than you would think. So this is actually the first time we've ever shown this software publicly. It's a new app called App Tuneup Kit. It's a family of apps that we have available. But this one's unique because, first of all, it's on target, it runs on your device. And very easy to use, one click, 60 seconds, you get results. And it is, hopefully when you see it, you are intrigued by what it can do. And then, of course, it makes recommendations. And this is the one area of the app that, I think we're going to see the most development on in the future. Right now, it's fairly crude. But we have some really great ideas how this is going to change. But the recommendations are based on the test results. And if you run it, you'll see the recommendations will change depending on what happens.
Do you have a blow-up of the recommendations?
Yeah, in fact, the great thing is it's available. We just posted it in Google Play a couple days ago, so you can download it for yourself. You can run it and see what's available. I think one of the most innovative features in it is the fact that it automatically rates your app against the top 20 in Google Play. And we eventually want to have every category in Google Play. So if you're a social media app, you're going to rate against other social media apps. If you're a driving app, you're going to rate it against driving games. And this feature is really useful. And to do this manually would take you literally days. To go through, download the top 20 Google apps, to measure the power consumption, to measure the thermal performance, to measure the mobile data consumption, to measure the CPU, GPU usage, and so on. And then come up with an average for the top 20, and then rate your app against that. And we can do that in 60 seconds.
You're gamifying performance. No, it's good.
Yeah. So, another very innovative feature in the software is it does power estimation. And that's important for two reasons. One, not every device will do accurate power, real-time power. And the second is in situations like tonight when I'm tethered. So if you want to do automation and script your device and other things, you have to be tethered, and that will affect the accuracy of the power consumption. So Nexus 6 does report accurate power. It does a really great job, but in a situation like this, I have to have it tethered, so that's where it automatically switches to power estimation. And it's not just limited to these 5 kind of key areas. There's a bunch of different data points, and this will grow over time. And then, of course, when you're done, you can save the results and you can compare them to apps, and it will give you the results in percentage differences, which is another thing that I used to do it manually. It used to take forever, so it's something that's really nice. These are just some of the different reports. Again, you can see this for yourself. All right, so how to use it? It's available on Qualcomm Developer Network. It's also available in Google Play. And we tried to keep it as easy to use as possible. So basically, you install it. The only things we have on the screen, the main screen, is the profile duration. There's a bunch of choices there, including manual. If you're like me and you have a lot of apps, it is nice to be able to search for the app. And then it remembers the recently profiled apps. So you select an app, and then use it like you normally would for 60 seconds. This is extremely important. We made it where, if you want, you can hit the back key and you can see what's happening in real time. And it's really cool because it's changing and you're seeing all this data. But in the process of switching and doing all that, you're actually affecting the results. So if you want good results, don't be tempted to use the back button. Just use whatever it is. If it's Facebook, use it like you would normally. If you're comparing it to Google+, you want to use it in the same manner. And that's the key to getting meaningful results. So once you're done, you're going to get a simple dashboard. and it's color-coded, 5 main areas, so we can tell at a glance. I see green, 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 yellow. Okay, so that's something that you want to look at more. You also want to look at, this is a game. Right now it's being rated against top 20 apps, so that's not ideal. But so then what I would recommend you do is change the category. So now I'm actually rating it against the proper category. And I can see there's a number of changes here. So on right now this is the power. When I rate it against the top 20 apps, it's higher power consumption than the average app. When I rate it against the top 10 games, I can see it's actually lower than average. Average is typically in this range. So we can see a big difference there. And of course, even if you don't know that 3.8 watts for the device is good, we do because we have the data. And if you just look at the color, you know, look at the text labels, it's pretty meaningful. We wanted to make it something that anyone could use. So once you've rated against the category, we recommend you save the results. Again, if you're playing a casual game, we recommend you compare it, do a detailed comparison against the same type of app. And you'll need to save the data to do that. And then here's an example. And then, of course, go through the detailed report because there's a lot more information there. The dashboard is just kind of something to get started with. And we could spend a lot of time here, but this tells me the per app usage. The CPU is 23%, actually pretty high for a single app. There's a normalized value. There's also the system usage of the CPU. That tells me a little bit about what else is running in the background, which is useful. And then I've got the average load and the max load of each core. This tells me my app is multi-threaded. It tells me this one is, you know, it's spiking pretty significantly. I'm pretty much maxing those out. Here's my GPU load, 85%. That's really high. This looks like a graphic benchmark to me. I can see the average and max GPU frequency. I can see the average power, 3.7 watts. Peak power is interesting, 6.2 watts. Power is very kind of bursty, spiky. That's interesting to see. Although the average one's really what you want to worry about. Battery temp is a pretty good indication of how warm the device is. And that's not a number to be concerned with. And then, of course, the processor temp is interesting. You see the initial temp, you see the average temp, and then you see the peak processor temp. So we can see that's a 10-degree delta on those. And you get the idea. Obviously, things like the screen resolution are important. Mobile data, it will tell us how much is sent and received, and both cellular and Wi-Fi. It's surprising how many apps will consume mobile data when you're on Wi-Fi. I don't quite understand why, but they do. So, and then here's, if you save the results, you can compare any two apps. So I have Asphalt 8 on the left, I have Need for Speed on the right, and then I get percentage differences in certain areas. And as a developer, these are actually surprisingly close, but there's a couple areas that people might want to look into and see if there's a reason. A lot of times there would be a reason, but it's just something you want to do. Okay, now something I want to jump in and actually show it. Now's where we get nervous, and we hope that it works the way it's supposed to work.
Live demo?
Live demo.
You know how risky those are.
Okay, so let's see if I can get out of this here.
So we're looking for that pile of smoke.
Yeah. So, in theory, okay, hopefully you see what I'm seeing. That's good. All right, so you can see the app, and
Oh, you're from the side.
oh, sorry about that. Let's see if I can stay out of the way here. So I'm going to start out with an app that hopefully is a good app, something that's, I just want to show you the kind of the range of different results that you're going to get. So, again, the key here is use the app like you normally would. So this is a media player, not very interactive. I select a song, I can play it. Adele seems to be popular, so we'll let that go for a minute. Right now I have it set for 30 seconds. We recommend when you do this For your own use, that you actually do a minimum of 60 seconds. That's really important for accurate power. We're done. 30 seconds. And this data is live, and if I can get rid of this. And again, you don't have to be a genius. I can see a bunch of green. I can see that power is 1.4 watt for the actual device power. We turn the screen to 100% brightness. And the reason we do that is screen brightness is the number one thing, the number one consumer of power. And it wouldn't be fair if you have one user who set their app at 20% and the other that sets it at 100%. You're comparing apples to oranges. And the minimum ratings, first of all, the scale is not right in the minimum rating. So the only way to do it, unfortunately, is to just set them all at 100. It's going to jack up the numbers. You want to keep that in mind, when you see them. But at least you're comparing apples to apples. So as you can see, this app is way below average. 1.4 is a good number. CPU, about what you'd expect for a media player. One of the reasons it's so low is because they're offloading. They're using something called audio tunneling, which offloads to the DSP. So it's using less CPU as a result. GPU, not a problem for a media player app. Thermal, it's green. Again, you may not know that 43 degrees centigrade is good, but it is. And this changes greatly depending on the processor type. All the rating is done per processor. So the results will change very much depending on what type of processor you have in your device. And then this app, the file was cached, so it didn't use any data. So that's a good app. Let's see if we can find one here that's maybe not so good. It's fairly shocking if you news apps and why don't you see that? Let's see here. Kevin, do you know why? Yeah, maybe. Should I close it?
Yeah.
Well, at least you can see it's really happening here. Let's hope that
Just disconnect and reconnect.
we can't blame this one on. I may have to. Here we go. Okay. So what I did is load. I opened a unnamed news app. It's one of the Google Play top 10 apps. And all I did, I clicked on one story. That's it. And I maybe scrolled a little bit, although you can tell from the GPU I didn't scroll much. Again, it doesn't take a lot of analysis. I see a bunch of orange and red and yellow and not a great story there. So, but again, you want to compare other similar apps, so you want to compare it with other news apps. And then if I go to recommendations, which I'll do, we should get some useful recommendations. So I go to Action Overflow, I click on Get Recommendations. It politely tells us that we're using too much power. It gives you some very basic things that most developers know about. Don't keep the processor awake. If you have the ability, dark skins save about 50% power. There's a lot of other things. And of course, this app is problems in a lot of areas. So there's CPU recommendations.
So these recommendations are standard recommendations, or they are for the application that we tested?
They're based on the test results.
They're based on test.
But this is currently a beta feature. We make it very clear up there. So they're really pretty crude and primitive right now. You're going to see this change dramatically once we have a lot more recommendations and we've had time to kind of just load. You're going to see that part of the app change a lot in the next couple months. But you will see if you do something like Geekbench, which is a CPU benchmark, you'll get CPU recommendations only. If you do a graphic benchmark or a heavy graphic app, you're going to get, it's very good about giving you relevant bench recommendations, but there's a lot of ways we can improve that. And now I want to show you one more one. We'll see if we can get, and then this is just a good example of how you want to use the app. And in a situation where it's loading like this, what I typically do is I let it do its thing. Let's let it finish. And then I would just go back because that loading time is not really indicative of anything that matters. So I'm going to stop profiling. I'm going to hit the back button, and we're going to do it again. And this time we don't have the loading time, so now it's a lot more relative. So if you just bear with me for 30 seconds here. But it's extremely important that you use it like you would, like a consumer would use it. And you'll see that the results change a lot if you don't do this. Of course, 30 seconds seems like eternity when you're... Okay, 30 seconds is up. And one of the reasons we talked about why we recommend you do 60-second minimum interval. Power is probably not accurate because 30 seconds, it just doesn't have enough data to give a good average. But you can see the results change dramatically depending on what type of app you're using. I would recommend if you're going to use this to test your apps, there's some best practices. If you go to the FAQ, I recommend you take a look at some of the best practices because it will make a big difference in the results. And then this is a starting point because it's really important that you use this to identify areas of concern, and then you're going to use other tools like the one Kevin's going to show you in a minute, Snapdragon Profiler. If you see there's a potential problem with graphics and you want to drill down, you want to look at that area and see, is there really a problem or not? When you use this on popular apps, you're going to find, there's a lot of popular apps that do have some issues. And as a consumer, I have a Project 5 phone, so I only have 1 gig of data. So when I see apps, this one I ran once and it used about 150 megabytes. This is after I downloaded it, after I installed it, after the add-on pack was installed. I thought I was done. So the first time I said, okay, well, I can't use that data, so I did another test. On my second time, I got another 161 megabyte of data. So, imagine if you have kids that are playing, this is a top 10 game all day, and every minute they're using 25 megabyte of data. It's pretty scary in terms of just the amount of data. And I honestly don't think these companies, obviously it's analytics, it's ad servers in most cases. You'll see ad servers, even on Pandora. Pandora, sometimes you won't get ads. If you do, you find out it's a really well-behaving app, very low power, everything's great. Depending on the type of ads, you're going to see dramatically different results in the scores because some of the ads, I don't know what they're doing, but they're using a lot of CPU, a lot of GPU, a lot of thermal, a lot of power, and a lot of data. So, speaking of analytics and ad servers and all that stuff, a lot of people don't know there's sites like MixRank where, let's say you find an app, so your app maybe has a problem, you want to find another analytics or another ad server or something. You can put any website or any app in. So this happens to be the BBC News app. They're actually using 23 different SDKs. And then you can see exactly what they're using. It will also tell you things that they used to use and they no longer use, which I think is pretty interesting. Because there's a reason why they changed. Yes?
What's the name of this website again?
This website is called MixRank.
MixRank.
And so it's a good way, like I said, if you identify kind of a golden standard, something that you want to strive to be in terms of your app, it's a good way to see what they're using, and it's probably going to benefit you as well. Obviously, you want to have some common sense. Right now, we only have 2 categories. We have a lot more data that we just haven't put into the app yet. So it doesn't really make sense to compare a benchmark or a 4K video encoding app to the Google Play Top 20, because it's mostly casual gaming apps and social media apps and stuff. So in this case, you just have to ignore the much worse than average, because it's completely meaningless. It's true. 4K encoding or high def encoding uses a fair amount of power. But the relevant thing in this case is the fact that this test is high def encoding. This is 4K video encoding. So the delta between the power is what's relative. And then, of course, the difference in thermals. You can see there's a significant difference in thermals there. So that's something you want to be aware of. Typically what developers do in situations like that, obviously your device is what it is. About the only thing you can do is limit the time. So with a lot of, this is a Google Camera app, a lot of these apps will put like a timer where you can only encode for 5 minutes or something, and that way they can keep the temperature in a reasonable limit. That's 55, even though it sounds high, it's actually not very high for a processor. And if we scroll down and saw the battery temp, it's probably not that hot yet, so it takes a while. So you do want to be aware of what you're seeing, and like I said, a benchmark is expected to be something that uses a lot of, it's going to use a lot of resources. That's its job. Benchmarks want to push things, yes?
So when you run this report, because even the same app, because Android is probably you have a different manufacturer.
Yeah.
The same app, I think, running on different devices, or the screen size different, and the
Yes.
feature different. You will have different
Yeah,
profile.
that's actually a really good point.
Yeah, how you
You don't want to use this to compare chipsets. You don't want to use it to compare the same app on different devices. And in fact, it's not even good to compare the same app on the same device on different days. Because one thing about Android is you have a lot of things happening in the background. You're going to find, if you do a test and you follow the best practices and you do another test, you'll find it's reproducible. You'll get very consistent results in most cases, in all the different areas. But if you run it the next day, you've got completely different things happening in the background. Even if you restart your device or shut down your device, it's a lot more complicated than people like to think it is. So we don't recommend that you use it to compare chipsets or other devices or any of that. You have your test device. I recommend you have a dedicated device. I have a couple. I have a Nexus 6 and a Nexus 3 and a Note 3. And I have almost no apps on them. If you want really good results, you don't want to have, on this, my main device has probably 300 apps on it. Not a good environment for testing. I don't know if you've seen any of the Google Talks where they talk about death by 1,000 paper cuts, but each app is syncing data. If you have hundreds of apps, there's a lot of background activity. So if you're serious about getting good power numbers, you want to have a device that's not running a lot of things in the background. So, okay, so we have something, we think it's interesting, we'd like to know what you guys think. We have a lot of ideas how we want to make it better. First and foremost, we're going to make a lot of changes in the rating and recommendations. Right now, we only support 4 chipsets. They happen to be really popular chipsets, probably 500 million devices or so, but we want to support more chipsets. The big thing is crowdsourcing. There's a lot of devices in the world, there's a lot of apps, we can't test them all. So over time, we want to put in a crowdsourcing cloud component, so as people run apps, we can kind of aggregate the data. Obviously, people will have to, it'll be like a benchmark. Do you want to share your results? And if they want to share, that's great. If they don't, that's fine. Graphics are probably the most limited part of the app right now. Right now, we just have a couple graphic metrics. We have the frequency and the load of the GPU. Frames per second is something we really want to add as quickly as possible. DSP metrics are something that Kevin has working on his tool, and we want to move some of those advanced features into here. And things like automation and scripting and stuff. So I want to leave some time for Kevin to show his stuff, just to kind of summarize what we've talked about. On Target software, it's free, runs on any device, Android device. It will compare any app with the top 20 in Google Play, show how it performs better or worse than average. We're trying to not have something that's subjective. It's objective. We're not saying it's good or bad. We're just saying it's better than average or worse than average. So, how does it compare with the best app in your category? It will show you 30 key areas. Is your app using all cores? Is it CPU bound, GPU bound? You'll definitely will know if you run this. I think this one is extremely important. Does your app use more power than the average app? And if so, why? And then things like analytics, you'll be shocked how much data some of these apps use. It's very surprising. And if you have unlimited data, it's not a big deal, but not everybody does. And the other thing about even if you do have unlimited data, that cellular radio uses a lot of power. So if you have all these apps that are doing things in the background that you're not aware of, it's going to increase the temperature, it's going to waste your battery life and all that. So we're going to switch over here. While Kevin is switching over, if anyone has any more questions on Tuneup Kit, I'd be happy to answer them. We'll start in the front.
Yeah, it goes to the top 20 apps. So for example, you add some servers as an Indus runner. Let's say I'm the biggest publisher of an Indus runner. Say it's to me like Loft, and I don't want to enable my competition to benchmark their app against mine. How do I prevent that from happening?
There's not an easy way. That was one thing that we did intentionally, is we never share the results of different things, because the goal of this app is to make better apps, not to shame anyone into the fact that they've got issues with their apps. So we're never sharing data publicly from one app or another, and apps are constantly changing. So if you run a GameLoft app today and you run it a month from now, the results are going to be pretty different because they're constantly making changes. So I'm not sure how meaningful it would be. We did discuss, having the company basically say, I don't want to share my data. It's something that we could look into. But the purpose is not to embarrass anyone. The purpose is educate and make better apps so everyone gets better apps.
One more question?
Yeah.
So I saw all this app you mentioned is developed in Android code. How about this hybrid app? The app we developed through through phone app based on JavaScript. Do you measure that as well?
We don't. We're looking just at the device as a whole, and you will see differences with different coding techniques. You are going to see differences in all the areas, but we're not drilling down on a code level. We're not looking at comparing whether one coding method is more efficient than the other. If the differences are big enough, you will see, even a web page, you can take the Chrome Android browser and you can have different web pages. And you will see, depending on what they have, you will see differences in power and other metrics. So it is pretty sensitive.
Great. Thanks a lot, Rick. And I think Rick's going to hang out the rest of the evening to get more questions. All right. Welcome, Kevin.
Try to speak loudly. My name's Kevin Hawkins. I'm the developer tools lead at Qualcomm. So the tool I'm going to show you and that tool, my team, is the team that works on these things. I have this presentation that I did a couple months ago. I'm just going to skip a couple slides because one of the things Rick hit on was throttling. But I also want to let you know about, in general, all the different Qualcomm developer tools that we have. And going across the board, you got kind of these phases of development, right? So create phase, we have a variety of SDKs that are available for developers. We have a compiler if you're doing native development. We have a couple debuggers for Eclipse and Visual Studio. And here we have Optimize, which is what the Tuneup kit now falls into. And what I'm going to show you is a Snapdragon Profiler, which is, since Snapdragon's our kind of core chip, our core SoC. And Snapdragon Profiler is meant to show you data across the entire SoC along with all the processes that are in the system. We also have Adreno Profiler, which is a graphics profiler, and Trucking Profiler, which does a little bit of what Tuneup does, and Tuneup is kind of taking it to the next level. And then deploy, we have a variety of platforms that you can use. If you don't know about them, the Dragon boards are pretty popular. We're starting to get into the IoT dev platforms as well. But all these are on developer.qualcomm.com. I forgot I had animations on this. So to give you some context, Snapdragon Profiler is what we call a heterogeneous system profiler. Heterogeneous meaning it's going across CPU, GPU, DSP, looking at networking data, power, thermal, device temperature, and so on. We built this to be as plug and play as possible with Android. Anybody from Google here? Okay, good. Android's not fun to work with at this level, but we really try. We did just release this at the end of July. I'd still consider this pretty early stages of the tool. We're still trying to add a lot of features, still trying to make it more stable, but it's starting to show some promise. And yeah, it can be used on any Snapdragon devices. This is what it looks like. I'll do a live demo as well. But just to give you some context, so we have what we call real-time mode. And this is just showing real-time data. And you can see this whole top section here is looking at what we call the system metrics. And that's basically stuff that's going across the entire system. So this first block is looking at all the CPU core frequencies. And then your next set here is looking at the individual utilization percentages for each of the CPU cores. And then your total system memory usage. And then down here we have a process that I had selected and looking at the frames per second for that process. And it's the process specific CPU utilization, which will differ from what you see across all the cores. Because like Rick said, you have a lot of stuff going on in the background that is kind of outside your control. The next node we have is what we call trace, and if you're familiar with systrace, we're basically taking that and building around it. So all this stuff, if you're familiar with systrace, should look familiar. CPU scheduling, I don't remember what all got selected here, but basically all the same systrace data, we collect that too. Down here is where we're starting to show where we're headed with this. And this is what we call GPU stages. And if anybody developed graphics applications or games or anything? Okay. If you did, it's 0 by the way. If you did, this is useful if you want to know what's going on in the graphics driver. And what you do is select your process, and you can see all the different stages that are happening within the driver itself. And game developers are particularly interested in this because they're looking to optimize, get the highest possible frame rate. But the phases and the amount of time that gets spent in each phase can have a major impact on performance. So what I don't have in the live demo is DSP. We just recently added DSP support, where you can get this GPU data, the systrace data, what's happening on the DSP, and we actually, the release we're hopefully going to put out in the next week or two is allows you to instrument your own application, so you can see all that correlated on the same timeline. And that's really the direction that we're trying to take this, where you can see across all these different components what's happening across the entire system and correlate all that stuff on the same time frame. The last one, since so no graphics developers. I can keep this one. Okay, so this is what we call Snapshot Mode, and this is right now more geared towards graphics developers. Anybody that's looking to optimize performance on the GPU. And what this in particular is doing is capturing a frame that was rendered for this demo. And so you can get all your resources, which include all your textures and shaders. You can see all the draw calls and state information that went into rendering that frame. And in the top left, you can actually double click on a pixel and see the history of that pixel to understand what was the ordering of events that went into making the final color of the pixel. But I'll kind of skip over that since we don't have too many.
Would that work for layouts and stuff like that? Unfortunately,
no. Not well. we've been trying to find a way to do that reliably. It can be done, but you would have to time it so that you were touching the screen, because Android only renders when you touch.
Okay.
And you need to actually get that rendering to capture that frame. So that's something we're still trying to figure out a way to do, because we're constantly asked about that.
So would it catch, it wouldn't catch overdraw or stuff like that? No, okay.
Now, the way the driver gets instrumented for this is, it basically needs to call into the GL driver.
Okay.
And it only happens if you touch or scroll or something like that.
I understand, that's great, thanks.
Yeah.
It looks great.
Can I have a question?
Oh, yes.
About texture compressions, one of the problems is the imagination, the flow of non-texture coming between the bus and the core, and the ball is all over the phone. So you have the same two-set of imagination, the two type of texture compressions, the format, the workflow.
When you get your textures, there's not much we can do with the Android, say, user interface side. When it comes to this, when you get your textures, you can see what the texture compression is and get more of that information by drilling down. I don't know if that kind of helps you at all, or?
No, because the imagination, they have two big repetition per color. So
Right.
The thing is, in the maximum rendering, how much you put on the screen is limited how much the volume and bandwidth the texture compression you can just set. So the visibility for that to be volume and bandwidth is very valuable. So how much you can render. So how much compression needs on the texture for me to follow enough the frame.
Okay, maybe we should talk after, so I can understand a little more. I think I'm going to skip over this slide a little bit, but basically the point of this slide is just that your device temperature and your battery performance is really what we need to be paying attention to, because that leads to your total user experience. The group I was talking to didn't really understand that. So Rick had mentioned thermal throttling, and one day when I was actually preparing for something like this, I happened to witness thermal throttling in the profiler, and it was an amazing moment because quickly took a screenshot, and I think it tells a great story. So this blue line here is your temperature. Over here, it was actually at 65 degrees Celsius, which is ridiculously hot. I had been running one of our high performance graphics demos that the larger group I'm in developed, and if you run that for 15-20 minutes, then it's maxing out the CPU, it's maxing out the GPU. We know how to use our processors to max out performance, and that's basically what this situation was. And so eventually the throttling mechanism got tired of that, and it's basically saying, look, we got to stop this now. And so that middle section is what happened. And I think the thing to really take away here is the CPU frequencies, and you can't see the actual values or anything here, but they're pretty much maxed out the entire time. Or pretty close to it. When throttling kicked in, your CPU frequencies just totally tanked. And that's not really what you want when you're developing an application that has any kind of response time. When those tanked, the CPU or GPU percent utilization went down. The battery power, it's actually a long story, but it's inverted. Actually, it got better. It started using less battery power because we were minimizing the frequencies that were activated in the cores. So this happens. System says you got to stop doing what you're doing. I'm going to throttle you, and it went for an entire minute like this. Basically, the demo I was using, that was a high-performance demo, was suddenly at about the 10 frames per second frame rate, simply by doing this. And it all happened because the device got way too hot. But you can see the device temperature drop down. And yeah, it's still 55 degrees Celsius, but that's something that the device can manage. And once it felt like it went long enough, after that minute, it went back up. And the thing with developers is, you may not realize this, but if you are doing this to your devices, it's going to kill your ratings. It's going to kill us as Qualcomm. We don't like it, but it's also going to kill your ratings because your application's not going to perform as well. So, any questions about that as I get set up to show you some live stuff? Yes?
Yeah, when you try something like this, though, you have to be connected to ADB and USB.
Yeah.
So power and thermals are kind of like screwable.
A little bit, yeah. And that's kind of why that was inverted. Now we can do ADB over Wi-Fi, which will help in that scenario, but in that case I was on USB, and that's why the inversion was happening, because the values aren't really accurate. You see more relative movement that way. Any other questions? All right, so I don't know if this microphone is helping or not. I have a Nexus 6 with Android M here, and I've connected to the device. So I'll load up the real time and drop in some CPU frequencies, and nothing's happened on the device. It's just start screen. I'll switch the graph. So you can see, there at the start, 300K. We're really not doing anything. All the jumping around is really just the background services that are doing their thing. The profiler does have a small performance hit. That is something to be aware of. It's a very common question. We do try to minimize it as much as possible. But that would also be part of your spikes here, is the service that we have running on the device to capture this data. Let's see. We'll throw the core utilization in there. And then I'll throw the temperature. So I had one of the guys on my team make a simple little demo app to help kind of illustrate some of the stuff that I showed you on the throttling. And so I've actually loaded it up, and you can see the device temperature spiked up. It went from around 32 to 37. Not a huge spike, but that's kind of typical when loading something like this. And over here, up here is all your processes, all the user space processes. We ignore all the system level processes. But I can select this process, and you can see that the metrics change. Let me get rid of the log hat here. All these metrics showed up, which are all the metrics that you can look at on a process basis. This is a graphics application, so I'll throw up the FPS. All right, so by default, this application runs terribly. We purposely set it up that way, and it's what we call CPU bound, meaning it's doing a lot of stupid things on the CPU. If I toggle the mode to turn it into optimized mode, interesting, the FPS is not doing all that great. But you can see with the optimized mode that the CPU frequencies are now much lower, and the CPU utilization is much lower. And I'll zoom out and you get a more clear picture of everything. And you can see, going from about, let's see, roughly in that 30-second time frame, maybe even a little more here. This is kind of the loading sequence in this general time frame, and then once we started running, things were still high, but the temperature was starting to drop because we weren't using all the loading CPU time, and then now we're executing. And it's interesting that on this device it's not getting higher FPS. But anyway, you can see the point. And this is a real-time mode. I don't have this hooked up to Wi-Fi or cellular, so I can't show you the network, but some of the other things, and this is, we were doing a demo at a show a couple months ago, and it was a very popular social network app. And we found out it pinged home every 3 seconds. And it was fantastic because I'm doing this demo, and I wasn't expecting this. But I loaded up on the phone, and I'm seeing the network spikes, which I didn't expect because it had just upgraded the app the day before. But what was great about it was the temperature spikes, and just like Rick said, when you use the cellular network, you're going to increase the battery consumption, you're going to increase the temperature. But it was right there. Oh, I think I lost my connection. But it was right there for everybody to see. And so, I kind of encourage you to, especially if you're using a lot of network data, to kind of throw the network data up with temperature and battery consumption, and you'll see the correlation and how much of an impact that can have. And kind of a good performance tip with regard to networking is you want to do it in bursts. You don't want to do regular polling, every 3 seconds like this particular app did. By the way, they've fixed it since then. You want to do more, even if it's a 3-second burst, you'd rather do that every couple hours than just continuous polling. Because every ramp up of that wireless chip is going to increase your power consumption.